Assalamu alaikum, respected students. Today we will discuss the new numerical related to the molarity, and mole fraction. Commercial nail polish remover usually consists of mixture of organic liquids and water. One such formulation contains ethanol, acetone, and water. A bottle having a total solution volume of 250 ml can be prepared by mixing 44 ml of ethanol, 150 ml of acetone, and 63 ml of water. Calculate molality, and mole fraction of ethanol in this mixture. Okay, major component of the solution of the solvent in this mixture is solvent acetone, but we uh, are asked to calculate only uh, the for ethanol molarity and mole fractions. First of all, write down the data given in the statement, density also given in the statement, and volume also given in the statement. Ethanol is 44 ml, density of ethanol is 0.789 ml gram per ml. Acetone 150 ml, density 0.784 gram per ml. Water 63 ml is given, and density is 1 gram per ml. Total volume is 250 ml. Now we have to calculate molarity of ethanol, and mole fraction of ethanol. First of all, change all the volume in the masses. How we can change the volume into masses? Multiply their volume with their densities. For ethanol, for acetone, and for water, when we multiply their volume with their densities, the mass of ethanol would be 34.716 gram, for acetone 117.6 gram, and for water 63 gram. Okay, now change these masses into their moles. How we can change the masses into their moles? Very simple formula: number of moles is equal to mass over molar mass. Divide their masses with their molar masses. Molar mass of ethanol is 46 gram per mole. Molar mass of acetone is 58 gram per mole, and water is 18 gram per mole. Okay, now we have calculated number of moles of ethanol, acetone, and water. Next, all the data which we need we have calculated. Now calculate the molarity. We know that formula of molarity is very simple: number of moles per liter of solutions. Okay, total volume of solution is 250 ml. Change the 250 ml to liter. That would be 0.25 liter. Okay, and number of moles of ethanol is 0.7536 moles we have calculated. Before the number of moles of from the number of moles we have calculated molarity is 3 mole per liter. Next, calculate the molality. For molality, we need the volume, not we need the mass in kg of solvent. And what is the solvent in the mixture? Definitely if 2 or 3 or more than 3 liquids are mixed, usually the liquid which is taken in large amount is considered as a solvent. Acetone was taken in large amount, so acetone will act as a solvent. Okay, so we change the acetone volume into mass, then into kg. Okay, moles, number of moles of acetone 0. Number of moles of ethanol is 0.736 divided with the solvent in kg. Keep in mind, number of moles of ethanol, but mass was given for acetone because acetone act as a solvent, and change that solvent from gram to kilogram. It is the necessary criteria for calculation of molality. Okay, molarity of the ethanol is 6.41 mole per kg. Now, last step, mole fraction of ethanol. Mole fraction formula is very easy. Mole fraction, for the calculation of mole fraction, divide the number of moles of ethanol with total number of moles. So we have calculated the number of moles of ethanol, number of moles of acetone, number of moles of water. Total number of moles is 6.27 and number of moles of ethanol is 0.7536. Okay, divide this number of moles with total number of moles. The mole fraction of ethanol is 0.1201. Okay, that is the numerical we have solved with respect to ethanols. If you are asked to calculate with respect to acetone, then use the number of moles of acetone. If you are asked to calculate the with respect to water, you use the number of moles of for water. Okay, hope so you got all my points. Thank you.